All right, guys, so welcome back. So as you remember from the last video, I'm going to put these on here to hold the magnet in place. I'm going to unscrew these guys, drill some holes in these retaining supports, and get that mounted and then get this guy installed. What I was thinking of doing, and I thought I had them, and I know I do, I've got a whole bunch of shrink tubing, the smaller size, but I thought I had some that were big enough to fit over this, like from here to here. Heat it up, shrink it up so it would really hold that nice and tight. I mean, I think it's going to be all right, but I had a thought when I was dreaming one night, and I'm almost positive I have that large shrink tubing, but I'll give it a go without it. Let me get these apart and get these mounted, make sure that they're going to work. All right. And then come over here. Here is the shafts that I 3D printed and put the resin in to make it stronger so that it won't pull apart for the 6-pole rotor. I might get that going at the same time. All right, so stay tuned. So if it ain't one thing, it's another. This was too close to this. It was unavoidable. I should have, but yeah, I couldn't help it because I made this first, not thinking of this. So I had to cut out a space, which really pisses me off. But it works really good. I tested the rotor in there, and it sits perfectly in there. It's far enough back. It may even be a little too far back. I'm going to check it out once I get this one done. And I'm running into the same issue with this one on this side. Poor planning on my part. Well, I didn't know that I was going to need this, but I should have made the whole thing a little bit bigger so I had more space. Excuse me. But there's always a fix. Stay tuned. So while I'm waiting for the printer to print out some more parts, and before I get the maglev put back together, I did have a viewer or a commenter, a person, I forget your name, I really apologize, commented on that they were having trouble printing out coils like this. And actually, the coils for me anyway are the easiest thing I ever printed out, but I learned the hard way that I can't print it out in one solid piece. I mean, I could, but it's a real pain. I'd have a lot of support that I'd have to cut out. So basically, I print these in 2 halves. So this and the center section will be one piece, and then the top part is a separate piece. On this one, I don't really know which is which. And ignore this shiny stuff in here. It was an experiment. I put some resin in there just to see. I'm not even sure why I did it. But anyway, this is 2 pieces. And you know, I started making my cores like this with just the small holes in them. And the only reason for the hole is so it'll go on the my coil winding machine. But then I started printing out coils like this, which is a lot smarter because I don't use as much filament. And again, this is the same thing. It's 2 pieces, and here you can see it. So this is a separate piece. This top piece, you can see the lip. I don't know if you can see it. Let me see. Well, anyway, take my word for it. You can see the lip. And so this was done in two pieces, right? This bottom edge plus the inner part of the coil, and then this part. And then I glue it together with this. number 16 acrylic. I think it's made by, I can't, side grip. Yeah, it's number 16 fast set acrylic. It isn't, it does set up quickly, but I still like a full day for it to cure. But this stuff works great. I have not had a coil fail, no matter what I try. And when you're winding some of these coils, the pressure that's exerted in this direction and this direction is tremendous. And I have yet to have one pop apart. So that acrylic is really good. And then of course I always, oh man, did I damage this coil? No. And then I always cover it with resin. I always put a layer of resin on just to cover the windings so that they don't get messed up. But yeah, print your coils in 2 pieces. Use really good acrylic. I wouldn't use crazy glue. I would go out and get this acrylic fast set cement, it's called. And you can see the name. Come on, focus you. Let me see if I can get it up close, if it'll focus. No, maybe if I go like this. There it is. SCIGRIP, side grip. All right, go back down now. I don't need you to focus anymore. All right. Yeah, so I would get that. You know, there might be better glues out there. I don't know. I've done a lot of research on it. I've tried a lot of different ones. That one works especially well with PLA. So yeah, stay tuned. All right. So I seem to be having an issue here. I think it's pulling too tight against the back wall here. I think I've got to put another spacer in there, because it's weird. If I undo this one and pull it away, this thing stays just like this, because it's pulling so hard against this magnet. And I checked the glass backing. It's not cutting into it, but it's definitely not flowing as free as it should. I mean, it's in there tight. It's not going to go anywhere. But I think I need to put a spacer right here to pull this out a little bit so that it's not pulling so tight against that. And I've kind of planned for this, and I've got it on the 3D printer now. It could run like this, but it would be fine. And it's not, there's no magnetic attraction between these two. It's definitely pulling. Let me see if I can loosen this, do this one-handed, if you could see what I'm talking about. I can't do it one-handed, but anyway, yeah, I'm going to print out a couple of these spacers and see what's going on. I started having this problem when I switched from using my way, which was to have a ball on the end, so when the ball touches up against the glass, there's almost no friction, to putting a point on it, because I was going to use some metal for the backing, but it still should work. So let me go and print out the spacers that I have and see how that works. Stay tuned. Otherwise, I'm going to go back to the ball. All right, so it's definitely better. Problem is, though, I can hear it. Oh, let me put that skirt back on. I can hear it grind. I can hear the point eating into the glass. That's no good. It's still got too much pressure going in that direction. This side's fine. So I have to think of a different back, or just go back to doing it like this with the balls. That really worked really well. I think that's what I'm going to do. I'm going to give up on this stupid point system. Go back to what I know. The balls work great. This thing is perfectly set up. I'm going to go back to using the ball bearings. Stay tuned. All right, so pretty easy fix. It's not done yet. I haven't even tapped it all the way to, or put the ball bearing in. But I was able to take off that end, that one end piece, get the metal rod, throw that shit out, and go back to the ball bearings. I got to make sure that the glass that's in here is okay, and I may have to put the spacers back in because I had to take the spacers out, but I'm thinking it should pretty much be the same. We'll see. But yeah, let me get going with this. Stay tuned. So you know what? I'm on my damn wit's end with this freaking thing. I don't get it. I've made tons of maglevs, and they've always worked. It's when I started messing around and changing the formula. So I had this guy in, and then the tip broke, so I gotta figure out something else. I just don't have the machine shop to do what I'd like to do. But anyway, I'm putting this is a great base. These are great ends. I'm putting this off to the side, and I'm going from a 6-pole rotor. I think this is the one. 1, 2, 3, 4, 5, 6. Yeah, I'm gonna mess with that guy because I am at my wit's end with this. I don't get it. Like I said, I've made a lot of maglevs, and they've all always worked, no problem. I don't know why this one is giving me such big freaking balls. Ah. Anyway, let me put this away and get the 6-pole rotor. I've got the resin all done. Let me get that up and running. If anybody can think of why this is not working, well, I mean, I kind of know why it's not working, kind of. I know I'm not getting any attraction between here. I know I'm not. This is far enough away. I'm wondering if this magnet is too powerful for these 2 rings. That might be an issue. I don't know. I'm going to have to sleep on it. Maybe take this whole thing apart. Leave this guy alone, but take this whole thing apart and figure something else out. Anyway, let me get the 6-pole rotor going. Stay tuned. Yeah, so I'm going to take these ends that have barrel magnets in it off of there and put it on here. Yeah, and I got some new barrel magnets. I forgot why. Oh yeah, because it wouldn't give me 8 in total. Oh, and actually, let me put this away. I was going to see if I can't get it on that bad boy, because that is a really good bearing. Yeah, let me take this one off of here and see about how I can build an adapter to hook this to this and get it centered properly. I mean, I have a centering hole, so that shouldn't be an issue. All right, stay tuned. This is going to be interesting. I need to make some kind of bracket like this that attaches to this, that'll then attach to this. Unless I turn it upside down. Here, hold on. Let me put you guys in a in a stand so you can see what I'm talking about. Hold on. Trying to get you clipped in here. All right. So, what I could do is, yeah, because it works the same way this way as it does the other way. And this way, I can just change this to fit down over that. Then it will be centered, right? And this guy will sit in here, no, oops, it'll sit in here, no problem. Yeah, that should work. That should work. Why does this fit snug on here, but it's not, so it fits snug on here, but when I turn it around, it's loose. These are the exact same size. The exact same size. There's literally no difference. Oh, I know what it is. It's this right here that goes around. Yeah, there it is. That goes around that collar or that lip. Yeah. All right, so I think I'd much rather do it like that, but this way affords me more opportunity. I could, because I do believe this lip right here is about the same size as that, and it wouldn't take me much to open it up so that it will fit around there. I could print some test pieces that fit like, I'll have to, no, I can leave that on. That's not a big deal. Because I can't think of a easy way other than printing out a mount like this. And this mount was specially made to attach to these, I don't know if you can see it, these 4 screw points. This one broke out. I'm going to have to get that guy out of there. Anyway, let me think on it. Stay tuned. All right, so it's been a while since I played with VCR bearings, and so I took this one apart to get some of this nonsense out of here. And it really just appears to be 2 bearings inside this housing and a washer down there that causes it to spin very long time. It's not, there's nothing special. It's not hitting anything. Like this top part here is not rubbing on. I mean, it's a really tight fit, but if I turn it around, it does the exact same. Well, I can't let it touch, but it does the exact same thing. Goes for a really long time. So it must be the combination of this absolutely polished straight rod and the 2 bearings. It's interesting. I didn't, yeah, as you can see, it doesn't really matter if I'm holding this or if I'm holding this. I thought it was something more than just the bearings, but these are the 2 bearings. And they're not particularly different bearings. I mean, I don't see anything really different. So it must just be the combination of the 2, because that's really smooth. All right, I got to still figure out, because I really don't want to reprint this bad boy, but drilling PLA to make holes bigger is a nightmare. Oh, you know what? I could do it backwards like this. So instead of, but I would have to figure out why. Let me see if it'll make a difference if I, no, I'm going to have to put a couple of washers down here, but tall washers, so that this bearing will sit above and not on. And then that almost, I could make an insert for this that fits over this. Yeah, let me check that out. Hold tight. And now that I think about it, I can make an insert for this piece right here. Yeah, I can make a sleeve for this that'll tighten this up, which I have no idea why. It's the same exact size as this. Oh, I've already talked about that. Duh. It's because of this. I can make a sleeve that'll go in there. And then I can put an insert that'll step this out, which will fit snug on there. That should work pretty good. Of course, I still got this nightmare over here to deal with, but I don't think I want to put this guy on this horizontal stand, or vertical stand, actually. The rotor is horizontal, but the stand's vertical. Yeah. Let me see what I can do here. First, I gotta, I don't think I need to worry about securing this. I can put this back on. Oh, that's where that special washer went, right there. I think, yeah, I can secure this guy back up. Like so. Then I can print out a sleeve. It'll be like a 1/2 millimeter thick. I probably don't even really need to even worry about that. What I need to do though is get this guy out, this broken bolt. Might have to throw some heat on there, get that guy out of there. But, oh, no, I'm going to have to take that off. I forgot I have this hole here. I could drill this out, but I don't want to. I want to make a sleeve. So I'm going to have to take this guy back off again. It's just stupid. I don't know why I put it back on. Come on. Come on. There you go. Yeah. I might have to figure out a way to keep this guy from flying off at high speeds. You know what I mean? Oops. Yeah, I'm going to have to think about this. I'm still really pissed about that maglev. I don't know what the hell's going on. Why it's not working. I mean, it's working, but not the way it's supposed to. And then I broke the damn tip. So I'll have to make a step down. So this guy, all right, stay tuned, guys. You don't need to hear me yammering. Stay tuned. All right, so I made this collar. So if I put this back together, I made this collar, and that sits on there like that. I'm actually printing out another one that has this piece a little bit wider. And also a little bit shorter so that it sits on this. I made this base piece a little bit wider, but this is a really tight fit. And so once I reprint the other one, this fit, I made this bigger too. This will be a tighter fit. And then I could, or I don't have to put glue on it. But yeah, this guy will work really good. He will work really good. It'll be like that. I mean, it's going to be more balanced than that. At least I hope it will. But yeah, I've got to take this guy off of here because I'm not going to use this one. This was just a test piece. But yeah, it's a collar. I designed it to have a step in it so that it grabs all that. Like I said, the other one's going to be a little bit bigger. So that should be good. What I have to do now is get these guys installed. And it turns out when you print, see, that fits good right there, right? But this side doesn't. And this is the side that I want to go in here, but it doesn't really matter because the resin goes all the way down to here. So it doesn't really matter. Yeah, I have to figure out how I'm going to do that. Yada, 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 yada. Yeah, because when you print, at least with my printer, I get what's called elephant's foot, where this is the part that was sitting on the bed. And it's always just a little bit wider than the top part here because of the heat and the weight and gravity and all that stuff. Not by much, but you can actually, in this particular instance, you can see it. But it's not a big deal. I can just take a file to this. If I wanted to go in here this way, I could just put it in like that. But I think I want to put it in like this because I want this end to be on here with the screw going through the way I have this guy here. So I'm going to take these off because I can just unscrew them and use them for this. So stay tuned. Yeah, and just so if you forgot what I was talking about, see, I've already unscrewed this, and I'll continue to unscrew it. And that screw's long and it goes into the resin. And that's what holds this guy on. Anyway, I thought I'd just show you that. Stay tuned. Really quick, I realized that when I was putting away my other maglev, or when I was putting away that that stand for the vertical, or actually the horizontal rotor, I found the original rotor that I ended up taking the two out for the other rotor. I could try this one inside that maglev. This has the smaller magnets in it, and this was working great, but it had that interaction. I think because it was too close, it may still be too close, but I'm going to give this guy a shot. Not now. I'll keep being out of frame. I apologize, guys. I'm waiting for this other piece to print. But yeah, I realize that I have this guy. So yeah, we'll see what happens. I got a lot of crap. Stay tuned. All right, so I'm going to use screws to hold the magnets in on here, but I'm going to glue these in there because these were made just for this one, just like the other one. So these are not interchangeable, but these guys are. So, you know, I drilled a hole much smaller than the screw, and right now I'm clamping 3 at a time because that's all I can really do, obviously. Even though I don't really think I need the clamps, I think and if I let it set like that for 20 minutes, this guy will set, because it does set quickly, but it does take, as far as I'm concerned, a full 24 hours. I think it even says in here, yeah, so working time 5 to 6 minutes, fixture time 10 minutes, and you got 80% strength, and after 24 hours it's cured. So yeah, let's let that sit. Let me go see how my 3D printed collar is coming out. It's just like this one, but much bigger base, just for, you know, more it'll be more secure. All right, stay tuned. Yeah, so I think I mentioned this before. I design in metric because it's just so much easier, especially if you have to sneak up on something. So I had made this a certain size and it was a little loose, but now it's a nice tight fit. It actually could be a little bit tighter, but that's okay. That's a good fit. And then I need to take this guy off of here. Oops. And see how this fits on here. I have to do a little bit of post work on this. Usually just takes a knife, just to get that lip. The elephant's foot can also happen when you use supports. And I use supports. I guess you really wouldn't call that an elephant's foot. But this guy should probably go on there just nice. I'll have to do a little bit more cleanup work. But yeah, and I think I still have to print the sleeve. Is maybe not, maybe just put some. Yeah, I've got about a 1/2 millimeter plate, maybe a millimeter. It'll be a little tricky to print out a sleeve a millimeter thick, but let's just try it and see how it works. Stay tuned. Yeah, that sleeve, excuse me, that sleeve fit really well. And if I was really concerned, I could screw this down to this, but I don't think I need to worry about that. The thing I need to worry about is when I put the rotor on here, I'm going to need to secure it in some way, and I haven't figured that out yet. Oh, actually, I think I just did. I think I'll print a 3D cap that goes on the top but slides down over this. Oh no, I can't do that because this doesn't spin. Yeah, that doesn't spin. I forgot. That's stationary. Huh. That's gonna be tricky. Yeah, that's stationary. So even I was thinking about drilling into that and yada yada, but yeah, well, I'm gonna have to think about that because this sleeve part here can only go up so high because of the indent in here. Oh, wow. Okay. I'll have to think about this. It's not impossible. A lot of the same sizes are the sizes that I use for everything. Yeah, I'm going to have to figure that out. So this does not spin. That makes it tricky. I can still put something in there as a safety measure, but it won't actually touch. Yeah, yeah, I can do that. I can still 3D print a stem that goes down over this and doesn't really sit inside here. It'll just float inside there just for a safety measure in case. Yeah, that's going to be tricky. I'm going to have to figure this out. Oh, man. Did not think about that. Did not think about that. I can put this back on, which stops this from coming apart. And I'll probably do that. In fact, I'll probably do it right now. Let me raise it up just a little bit. Nabbit. All right. Stay tuned, guys. I'll have to figure something out. Stay tuned. I'm going to print out this sleeve. So in looking closer at this, there's no way I can, there's not enough space for even, I tried printing a 0.75 millimeter shim, even a 0.5 and a 0.4. There's just too little space. So what I'm going to do is I'm just going to probably wrap a piece of tape around this and set it down in there. That's probably even going to be too thick. What I may do is just put a coat of resin on here, let it dry, and then set it in there. Or just put the resin on there and set it in there. I think that's probably the best shot. Yeah, can't 3D print everything. I mean, you can, but it's not always going to work. So let me get the rest of these stems on there, or poles, or leads, or whatever you want to call them, and get this puppy together. Stay tuned. All right, so I think while I'm waiting for that to dry, in fact, let me set it up over here. What I may try to do is resurrect that maglev to see if that other one with the smaller magnet will work. So stay tuned. All right, so some early testing. Let me see if I can get this thing to stay like this. Some early testing where I was able to get that in there. Obviously, it's too small for this particular rig. I was able to get it in there and it spun freely. So I think it may be the size of, I don't know what you'd call this, the rotor end magnet. And I think I have more of these smaller ones. If not, I can take it off of here and put it on the longer rotor. So let me see if I can get that going. Stay tuned. All right, so I ended up taking the old shaft out, and I have a new shaft. I don't have anything attached to it yet, but it's long enough because the end is going to, yeah, so it should work. It should work. While I'm waiting for this guy to dry, let's see if I can get something going here. Stay tuned. All right, so what I do when I 3D print stuff, I 3D print a bunch of extra stuff just in case. And I've got two of these extra pieces here, which should work great, right? So I put the smaller shaft in there, I'll have to probably 3D print at least two more parts, kind of these things that have wings on them, or whatever you call them, edges, that'll slide on there and go over. I wonder if we'll go over the shaft. Anyway, yeah, I always print extra. So I got these two. They should work just fine. Yeah, and then I've got plenty of ball bearings. I don't need to reuse these. But yeah, I got to make sure that I have the smaller shaft that'll go in there, that'll fit on the magnet. Right, and there's the two magnets. They're pretty beat up, but they'll still work. Just the chrome plating, or whatever that plating is that's on these neodymium magnets. I'm not sure what that is. It looks like some kind of a chrome. Anyway, let me see what I can cobble together before I have to go hit the 3D printer again. Stay tuned. All right. I got two things going. I've got the new rotor there with the ball ends glued up, and I'm doing these guys, north, south, north, south. These are all glued in. Oops, dag nabbit, be careful, dude. And these are glued in and screwed in. Oops, sorry. Yeah, these are north, south, north, south. These are glued in, and then these are screwed into this. You can see the little screw hole. Having some problems though. The screws I have are too long. So as I'm screwing it in, it's actually pushing this out because it's bottoming out or something's going on. But so I found some shorter screws, but I don't have enough, so I'm going to cut these off. They're brass, so yeah, they're brass, so it's no big deal. So it's late. It's like 10 o'clock at night, Pacific time, PST. I'm going to let this sit overnight. I'm going to finish screwing those guys in probably, or maybe I'll just bag it for the evening. What I'd like to do is, right now I've only got the magnets and the end caps on the magnets glued in. I'd like to get the ball in there, but that's not a big deal. Damn, I gotta remember to keep the stupid ass phone up so you guys can see what I'm talking about. Yeah, so that's very dangerous, having those super strong magnets right next to those super strong magnets, because any second now they're going to go flying up there and shard and shoot me in the eye, and then I'll be blinded, and woe is me. I shouldn't laugh. When I was trying to take this magnet off of the other rod, I had it inside my vise, and I had this underneath it like that, and I was hitting it with the hammer to try to knock it off, and it went flying through the air and landed over there, and I didn't hear anything else, so I know it stuck to some metal somewhere. I had a bear of a time finding it, and what I thought it had landed on was these. I haven't shown you guys these. These are these are probably the most powerful magnets I've ever encountered. My brother-in-law gave them to me. They look like, they look like they were part of a rotor assembly, but they are scary strong. I don't know what I'm going to do with those yet. I'm going to do something with them. But let me get this going. All right, that's all for tonight. But for you guys, it'll only be a second. Ciao. So that's probably a disaster waiting to happen. I'm actually surprised that this isn't causing more of a breaking. And I just pushed that by hand just a little bit. That shows you how good that bearing is. And it's still going. I got to be really careful, though, because it will catch it at some point. Look at that thing, still going. That thing's going to fly. I'm going to have to get better screws. Yeah, I don't like the way those screws, I'm going to have to go hit Ace Hardware tomorrow and get some better screws. I am not going to run that thing like that, even though it's freaking gorgeous. Look at that thing. It is still going. Hey, maybe it's free energy. Maybe I discovered something and these two magnets are cut. Yeah, not likely. But it's going an absurd amount of time for just a little spin by my hand. I wonder how long it's going to go for. Maybe it is getting some kind of interaction with that guy. No, I don't think so. It's a disaster waiting to happen. That's crazy. Oh, and instead of that ring that I was going to print, I think I mentioned this before, I just put a piece of tape around there and it fit nice and snug. I'm going to bolt this to this stand here on the outer edge here, so it'll be like way out here, so it won't interact at all. Let me see. Yeah, no, I don't feel any interaction. Well, there's one way to find out. Let me loosen this up. Oh yeah, it is interacting. Look at. I forget how strong those freaking magnets are. So if I bring it over here like this, yeah, that's not interacting anymore. So I could probably bolt it right there and it'll be all right. Whoa, that's going to suck it right in. Yeah, I better not play around. I'm going to end up in big ass trouble. But yeah, that's going to be cool, man. I'm going to try that one tomorrow and this one tomorrow. So one of these is going to work good, but I'm not going to do it the way it is now. I'm going to wait. Oh yeah, it's definitely interacting with that one. Let me try that one over there. Yep. And now that one there. Yeah, let me tighten this back down again so we don't have a freaking disaster. And I think I could tighten it down with it pointing that way. Let me see. Yeah, no, it's still interacting. Ay, ay, ay. I'll have to get a different stand for this one. I've got plenty of acrylic, so I can make a nice stand. I think I'm going to try it with the wood again, too, because I really like that. All right, guys. Good night. All right. Good morning, guys. Starting off early this morning. So this guy's nice and dry. Let it set overnight. Been to the store, got some new screws, ones that are going to fit here perfectly. And I've also gotten myself some of this JB Weld with steel reinforced. Now, I don't think there's enough steel in there to mess with the magnets, and obviously there isn't. But I'm going to use that. I take these caps off, take the screws out. The little barrels here that have the resin in them, since I've screwed in there once already, it's going to be a little chewed up, and I want it to be tighter because this thing is going to spin like crazy, and I don't want that to fall off. Yesterday I made the mount for it, so today I'm going to redo the screws. I'm going to grab an acrylic base so I can mount this to, and mount a coil to it, and we're going to try the new, let me grab it, the new circuit, which is killer. It has, let me take it out of the bag if I can. It's hard to do this one-handed. I should just, there it is. This is a killer circuit. It even has an LCD display letting me know. So this is a Hall circuit with several outputs. A toggle switch, so I can switch between the outputs, either have them both on or just one. But I've been waiting. I was going to do it on the maglev. I still probably will. But my freaking arthritis in my hands is killing me. But I'll be damned if I'm going to let that stop me from doing the hobby that I love. So stay tuned. All right, so I decided to try to just replace the screws I had in there with the newer ones I got, and it seems to be tight enough. I don't think I need to worry about the filling the holes with JB Weld. Yeah, I don't think that's necessary. I'm going to go through each one. If I do find one that's really loose, then I'll consider doing all of them, but I don't think so. It seems, because I drilled the holes really undersized, so it seems to be grabbing really tight. So I'm not going to worry about it. Stay tuned. All right, so I'm debating on whether I should use the ball bearings, and I made sure that I made the cup size perfect for a ball bearing to sit in there at the right height. Or if I should put a piece of solid steel in there and just round it off. I would have to find a piece of steel that's the exact width of the internal ID of that end cap, because I think it would, I don't know, I'm going to have to, because it really all depends on the distance between the magnet here and the back plate. I haven't measured that yet. And I think if I use different lengths of steel rods that are rounded over and polished, so it would be very much like a ball bearing, I could adjust the distance to better fit because I don't want it to be pulling too tight against the wall, but I also don't want it to push it out. I want it to be in that equilibrium, because that's where you get the best action, the best spin action. So let me look around and see if I know I have a bunch of steel. I'm not going to try brass. I could do it with brass, but I've never tried it rounding over the brass. Now that I'm thinking about it, that might work well. But I think the steel is better, especially because of the glass back here. Let me take some measurements and see. I always have the ball bearings I can fall back on. So stay tuned. Yeah, so I just took some measurements. Let me show you what I'm talking about. So here's the end of the magnet, right? And the ball bearing would sit out about here. So about 20 millimeters. Yeah, about 22 millimeters or so. And if I come over here and I measure to the front part of the larger ring magnet, which is right there, and this edge here constitutes the back edge. Actually, this edge here, because the glass sticks out about that thick. If I come here, you can see I'm way off. I'm almost 10 millimeters too big, or too. Now I can easily fix that just by taking these two spacers out. But it will still it'll still pull against this magnet up against the wall too tight. So I think by going with, and I was even thinking I can put a bolt in here, cut it off, round it off, and that would work really well. Let me see. Let me play around here and I'll bring you guys back. Stay tuned. Okay, so major change in plans. Instead of doing all that, I'm going to, this is the back that goes on here. And I've already extended it by 5 millimeters. I'm going to print out a couple of more of these discs at 5 millimeters. And I'm also going to go back to the metal backing. Yeah. So I'll just figure out how many I need to overshoot, and then I can adjust with the shims back here. Something like that. Stay tuned. All right, I'm getting there. Here's the acrylic base. This is screwed down. That should be pretty secure. I'll put my coil right here. I've got the ball bearings glued on there. I'm printing out the backing for that. I've got this one done already. And I know it will fit because I've taken exact measurements. So we should be getting a couple of first runs today. I know at least from this guy we will. Stay tuned. All right, so it turned out I made the pieces too big. And so I was going to go and do all kinds of more printing to make more spacers for this. It's, cat chasing his tail. I decided, wait a minute, I can just use nuts as spacers. This one, for some reason, needed more. It needed a nut and a few washers. But now I'm pretty sure it should work. So let me see if I can. So the hardest part is getting this thing in here and pulling this over and locking it down before it pops out. Let me see what I can do. Stay tuned. Now that's the way it's supposed to work. Yeah, it must have been either the backing, because it was up against the glass. This is a little unbalanced, but that's all right. or the other magnet was just too strong, the one that I had on the end here. But that flows really smoothly. I think I need to tighten it up though a little bit. But yeah, let me see if I can get a first run out of this. Yeah, so I think it was a combination of a couple of things. I think it was the magnet that I had on the end of this guy was too tight. Also the backing. I went back to the metal backing, that little brass piece, and it seems to work really good. So yeah, I'm really psyched about this, finally. And that magnet's strong enough, it's not going anywhere. Yeah, it's strong enough. I don't know why the other magnet was too strong. I didn't think. Anyway, I don't really care. It's working. Let me set something up. I'm going to set up a test circuit first. I'm not going to go for the good one yet, just to see it working. Yeah, so I've got my new coil stand set up. Unfortunately, I got to drive my kid over to his girlfriend's house. Oh well. I shall be back. Of course, me telling you guys this doesn't make any sense because you don't have to wait. It'll literally be like a second after I close this particular scene down. Stay tuned. So it probably won't do it now, but the 3 times that I started this, it self-started. Let me see if I can get it to do it. No, of course not. But we're getting plenty of back EMF, and I don't really have the hall sensor in the best spot. It's really quiet. Let me turn off the fan. Hold on. Oops. Yeah, it's really quiet. That seems to be a good spot right there. Yeah. Unfortunately, guys, I'm going to have to call it because it's like 100 degrees out. And in this garage, it's probably like 120. But I did get, finally, my maglev up and running. Let me turn this up a little bit. Oops, that's a little bit too much. It's got a little knock. Oh, that's just the bass. Yeah, it's working really good. Again, I don't have this thing tuned. I don't, pull the coil in and out. It's just way too hot out here. But I wanted to show you that I at least got the maglev going. Next is that guy. All right, guys, thanks for watching.